Hi, everybody. How are you doing tonight? Welcome to the April 7th version of the Virtual Night Sky. This is a program, if you're joining us for the first time, we've been doing this about every other Wednesday, and we've been doing it for almost a year. And we expect to keep going and using that same format going forward indefinitely. So we'll just keep it moving no matter what happens. We'll go through the summer and into next semester. And so if you kind of look forward to every other Wednesday night. And I think that would be great. It's been fun working with everybody. Tonight happens to be an anniversary. April 7th is the anniversary of the launch of the Mars Odyssey orbiter. That was really very important to my school and to ASU, and it carries a camera called Themis. And this has been going 20 years, and we're still using that camera. I don't know if you know this about missions, but they're organized to have a lifetime. They're sort of the mission would be successful if it lasts so long. Usually that's like 18 months, or it has its objectives and it meets them. And then this equipment and this hardware in this particular case, like others, has just been lasting and lasting and lasting. And so the mission continues. It's still turning in great science. And we're really excited about that. So April 7th, who knew, launched 20 years ago today, Mars Odyssey. Uh, and we sort of appreciate that. I've got just some housekeeping things to kind of go over tonight, but first some introductions. So my name is Rick Elling. It looks like Robert on the screen, but my name's Rick, and I'm the director of the Marston Exploration Theater. That's the room behind me in the background here. We started this program because of COVID, very specifically because of that. Myself and my colleague Meg Hufford, who's on the program tonight, she also she and I kind of are the hosts. We invite people to our facilities. We do programming in this theater. We have lots of school shows. Our normal operation is to have lots of visitors and lots of people come see us on campus. We're going to do that again. So soon enough, in the next coming months, we'll be kind of looking for ways to get people back on campus. We expect to be full-blown visitorship probably by the first of next year. We'll see how it goes, but that's our expectation, and that's what we're going to try to do. Until then, we have been finding ways to talk to people and be in your living rooms and communicate with you and keep programs going. And so if you're joining us for the very first time tonight, welcome. If you're a kind of a periodic visitor, I think we've got a great program for you tonight. And for those of you that have kind of been with us for almost this entire full year, we love your loyalty and thanks for participating. Joining me tonight, of course, I already introduced Meg Hufford, my colleague. Kim Baptista is your webmaster, and she is the one that is kind of organizing the communications. And you're actually going to see her tonight. She's actually going to be on screen. She's going to be part of our presentation tonight. So we'll look forward to seeing Kim in a little bit. And then 4 students tonight, some of the regulars that you've seen all along. We have had Alicia Hyatt is one of the workers in the Marston Theater. She's been with us for many, many years, and she's also a regular on this program. Alex Blanche and Spurti Kachare are docents in our program, and they have also been helping out. They field questions and work in the background to make everything wonderful. And then joining us tonight, Justin Baez is also with us, a student. His interest is more geological and paleontology. And so we'll be hearing from him at future events, and he's here to help out tonight as well. Just so you know, we do run closed captioning. If you're seeing it, if it's sort of like running across the bottom of your screen, that's important to us, and we do that. But you have a choice, and we get this comment every once in a while. You have a choice of turning it off, so you can turn off your own closed captioning if you don't want to see it. There's a live transcript button that says CC on it, or live transcript, and underneath that button, push that, and it'll give you an option just to turn it off if you need to. So that's good to know. We don't allow chat, so chat doesn't happen in the webinars, but we do want you to sort of work with us and communicate with us. So use the question and answer button. Under the Q&A button, you can formulate questions, you can get them to us, and they are responded to completely all the way through the program. by the students. And then we pick out several questions that we kind of will take periodic breaks during the show tonight. And we'll pick out some questions for people to see and I'm sorry for us to answer live, and we'll see how that goes. So, but please do that. And then if you're a student, I always sort of try to call this out, not to call you out and embarrass you or anything, but we'd sort of like to know. So if you want to ask a question, please do. But just kind of give us your first name and maybe a grade level. So say not first and last name, but just your first name, what grade you might be in, and then formulate your question. We'll try to get to that. We want to know how many young people, especially K-12 students, are participating in the program. Tonight, I know also that this invitation went out to an organization that I'm a part of, called the Society for Cultural Astronomy in the America Southwest. That actually is a long name for a group of people. We've got about 60, 65 members, and we kind of deal with essentially the very unique history of astronomy in the Southwestern United States, not only the native indigenous cultures, but also the history of astronomy and technology that comes from the Southwestern United States. And so hopefully there are several members that picked up on the invitation, and welcome people, and good to see you here tonight. So tonight we're going to be talking a lot, and we're going to go back to some of the basics. We started, as I said, about a year ago, and when we started, we felt it was kind of important to just kind of go through some of the motions, some of the mechanics of how the sky works. Why do we see what we see when we see it? And so tonight we're going to really concentrate kind of on constellations and why constellations change seasonally. And so 2 weeks ago, we spent a lot of time on the vernal equinox, the beginning of spring, and how the season started, and how the sun relates to the earth, and how it changes winter, summer, the cycle of a year's seasons. Tonight, we're going to talk about how the parade of constellations joins that seasonality, and so how certain seasons bring different constellations to the table. So we've got some technical stuff. We're going to work on some simulations, and we're going to work on some planetarium software. And then later in the hour, we're going to give you a little resource. We want to invite you. We're going to teach you how to use our website and kind of look for information. And then we're going to get an update on the Perseverance rover, especially, right? What's the name of the helicopter? Does anybody know? Especially Ingenuity, and how it's this is Ingenuity month, and hopefully we're going to see that little helicopter fly within the next several days. And Alicia will give us an update on that. So that's where we're at today. And I think that's going to be kind of fun. So I'm going to share my screen with everybody. Oops, not that screen. I'm working 3 different computers tonight, so I apologize in advance if that sort of becomes clumsy. I hope we sort of are able to do this. I'm going to optimize that. I'm going to go to here, and I'm going to go share. And what you're going to see here is essentially the night sky. And I'm going to just make sure that we are right now. So I'm going to go to right now. And what you're seeing is the sky from the roof of our building. So this is the building I'm in the virtually is ISTB4, Interdisciplinary Science and Technology Building 4. It's on the ASU Tempe campus. The Marston Exploration Theater in the background is on the ground floor. It's one of the public spaces, but it is also a 7-story building. And on the roof, there's some observing stations, places where we can get a good look at the horizon. So what you're seeing there is on the roof of our building, that's South Mountain. We're looking exactly south. Actually, I can kind of show you some little azimuth markers, so you'll see how that works. 180 degrees means south. I think everybody knows that part. And so, this is actually a simulation of the sky, and what you're looking at is the sky right now. But what I wanted to do is just talk about sort of how we engage the sky. I'm going to move over towards the east. I'm going to start time moving a little bit. So you'll see stars moving in the background. And when we sort of get that going, there it goes. And I know sometimes this looks a little chunky over Zoom, so this computer is trying to do an awful lot of work in the background, and so it will catch up. I'll try to go slow as it's trying to regenerate the screen here. But notice what's happening is the stars in the sky. As I've sped up time a little bit, we're moving forward about 10 seconds every second, if you want, 10 times as fast as things go. And you'll notice that the stars, if you stood out there and watched them long enough, they appear appear to rise above the eastern horizon. They appear on the horizon, and then they just kind of move up and get higher on the sky. Let me try this. If that isn't enough to try for my machine to try to calculate, I'm going to add some trails here. And so you see, this is the movement. This is what's going on. And so sometimes I kind of, with students and things like that, I ask this question. We often just generically talk about sunrise, sunset, stars going up, stars rising from the eastern horizon. But you know, right? And I know in reality, the stars aren't going anywhere. The stars are just doing they're moving by our perspective. It's the Earth that is doing the spinning. It's the Earth that is turning us towards the eastern horizon. And as the Earth kind of moves in that direction, then we start to see this phenomenon rising. Let me put those trails on just one more time. If you notice, if you were observing very carefully, uh, you probably notice that they're not going straight up. They're going up at something of a little bit of an angle. The reason for that is where you are on the Earth makes a difference. Here in Tempe, Arizona, the top of my particular building is at 33.5 degrees north latitude. And so our position on Earth kind of just shows us how we're going to see the sky. So that motion of stars moving, appearing in the eastern horizon, and going up on an hourly basis is part of our sky. Let me just sort of like spin around a little bit. Let's just go. I'm going to kind of just take us back to the south, but I'm going to go all the way to the west. And you probably have figured out already that if the stars rise above the eastern horizon and get higher in the sky as the evening goes on, then in the western horizon, the opposite should be happening. And sure enough, that's what's going on. Let me turn the trails on again. You'll see sort of their movement down towards the horizon in the west. And so, if you want, we could characterize the movement of stars over any given period of a nighttime as appearing in the eastern horizon, arcing across the sky very slowly, hourly motion all the way across, and then eventually setting in the western horizon. And then that angle of set is just exactly the opposite of the angle of rise and relates to our particular position uh, in the night sky. So I'm going to just kind of take us to the north here for a moment, show you something kind of important over here. Let me just restart the trails because sometimes they get confused if I move a little bit. So now I'm looking straight north. And if in the east, the stars rise from the horizon and go up, and in the west, if the stars start in the sky and move down, in the north, something really, really unique happens. And what you're seeing here is the circumpolar motion of stars that are in the northern part of the sky. The star that appears not to be moving is Polaris. It's the North Star. It actually is almost exactly, not exactly, but within a degree of directly over your North Pole. And it stays like that always. And when I say always, I say lifetime always. Within in several thousands of years, it moves its position away from the North Pole. But for us, for our parents and grandparents, for our kids and our grandkids, the North Star is going to be the North Star, and that's going to be in the thing. And so you're seeing here that there's a group of stars that neither rise nor set. They just kind of go around and around in this circumpolar motion. And the travel around this particular circle, it kind of helps you represent a 24-hour day. You could look at this like a giant 24-hour clock. And I'm going to get to a little bit more of that later in the evening when we're kind of talking about stars you can look at tonight and what's going on in the night sky. We'll take a look at that in a more general way. But before then, I also wanted to talk about there's two things going on, right? This Earth is spinning. And that's what's causing these motions that we can notice during an evening. We can see the rise of stars. And if you watch long enough, or you go back out and check an hour or 2 hours or 3 hours later, you'll see that those stars changed position. That's the spin of the Earth. That's that 24-hour cycle. But the Earth is doing something else, right? The Earth is also revolving around the sun. On an annual cycle, it's going around. And we can actually, if we know what to look for, we can see both of those things happening. not only the evening movement, right, in a nighttime hourly movement, but also week to week, month to month, season to season over the course of a year. There's also a movement, and we want to capture that as well. So to do this, I'm going to have to just sort of like fumble around with some changes. I'm going to get out of this particular area here. I'm going to move us up into space. And I think some people have seen this before. I have to actually sort of like move this my screen all the way back around to the south, or nothing will work right. You can see that the Earth is right there in our frame. So now we're off the Earth and we're up in space. And what I'm going to do, you'll just have to watch me do it. I'm going to set up a view here where we get to see the Earth and the sun next to each other. And I'm going to manipulate. I'll show you what I'm doing as I do it, but I just sort of remind you this is what our Earth looks like. And the sun shines on half of the Earth at a time. You can see Africa is daytime in this particular scene. South and North America are nighttime in this particular scene. I'm going to turn on something. You've never seen this before, but I'm going to put two just sort of like dot markers on the Earth right now. Just a couple of dots. Here they go. So the green one right there is right on top of Tempe. If you look out the window right now, everything just turned green. Just kidding. No, it's just sort of just to represent the where Tempe is on Earth. And then if I spin around the Earth to the opposite side, that green dot is matched by a red dot over here. You see that? And so this is exactly 180 degrees around the Earth from us. It's in Afghanistan. Now I'm over Afghanistan, but it's not exactly opposite us, because if it was just, Tempe is 33 and a half degrees north, opposite us it would be 33 and a half degrees south. No, I'm actually using the same latitude. So the green dot represents Tempe, and the red dot represents Afghanistan. If I get a view from the top of the Earth, kind of looking down, you can see the two together. You see that? See how they are right there? Okay, now I'm going to make some changes. So I got to get out into space, and I'm going to just kind of do some things. I'm going to blow up the size of the Earth and the size of the sun. So it's going to look like they're just right next to each other. Let me just sort of like start that. And then there's always another button to press. I'm going to kind of put the sun in the center of the screen here. There it is. We'll find the Earth in the screen here someplace. There it is. So I'm going to kind of move it around this way. I just want to get exactly the right position where I'm going to be able to illustrate this in the best possible way. So let's do this. I'm going to kind of move this over this way just a little bit. All right, so here you got it. I'm going to move back just a little bit. So we're looking at the North Pole of the Earth. So we're looking down, if you want, at the orbit of the Earth around the sun. And I can just move forward here a little bit. Let me just kind of like get the Earth moving. I'm going to turn this so that the red dot, remember the red dot? We go forward just a little bit more. I'm going to go around another cycle and watch what happens. I'm going to move it so that the red dot appears to be facing exactly the sun. So right now you see the green dot, noon in Tempe. Let me move Afghanistan around until it sort of gets into view. And so here we go. This is the view I wanted to show you. So in this particular scene now, it is noon. Sun is straight up overhead in Afghanistan. And it is midnight, right? The Tempe is completely opposite the sun. So we're looking straight out into space. Whatever is overhead is exactly opposite the sun. Let me move back just a little bit, and I'll give you a little arrow to do that. And let me, before I do that, I'm just going to kind of show you this motion. So let me just move through a little bit, and you'll see that as the Earth spins, in a 24-hour day, we call that solar time. Some people, you could also say that's the basis of civil time. That's the one that your clock operates off of. The idea that somewhere around 12 o'clock every noon, the sun is directly overhead. Somewhere around 12 o'clock every night, we are opposite the sun. It's midnight and we're facing completely away from the sun. And you can see how in this particular case, Phoenix and Tempe and Afghanistan just trade places. So that's kind of how that works. Let me go backwards just a little bit. I'm going to just reset up Uh, this is noon in Afghanistan, midnight in Tempe, Arizona. And I'm going to just sort of put a little indicate on it. I'm going to take an arrow and point it out into space this way. So at midnight tonight, if you look straight up overhead, straight up into the sky, there will be a star, a cluster of stars, or something right over here. We call that the zenith. And so noon Afghanistan, midnight here, there's stars directly over your head. Now, watch this. I'm going to try this. I'm going to just basically move forward really fast. It's going to look a little chunky on your screen because the moon will sort of, or the earth will jump around a little bit. But I want to move forward several days, and I'll give you a little counter so you can see how far we're going. I started out on April the 7th. You can see we're up to about April 16th now. And let me just move forward into about April 20th or somewhere around there. Doesn't matter. And I'll start to slow it down a little bit. And I'm going to put Afghanistan at noon again, right about there. All right. So in 24-hour days, that cycle of noon to noon to noon to noon is the spin of the earth. And we've just played that forward. Now we're on April the 22nd. So we're about 2 weeks from now. But look what happened to our midnight position. Look what happened. Now, if we look directly up in the sky at midnight, we're not looking where we were before. We're actually looking over here. So what's the difference? Of course, you're seeing two different movements. The daily motion, your 24-hour day, your solar time, is juxtaposed to what we call star time, or astronomers call it sidereal day. A sidereal day is a little tiny bit shorter by 4 minutes than a solar day. What does that mean? 4 minutes. What big difference could that make? And what does that mean? So essentially what happens is we come back to the same part of space in star time, right? 4 minutes shorter than a 24-hour day. They even say 23 hours and 56 minutes after you start, you get back to the same star. Then it takes another 4 minutes for the Earth to align to another noon. Okay. 4 minutes, that's not a big deal, is it? You wouldn't even notice 4 minutes day to day to day. But over time, that adds up. Let's do the math together. I'm going to just sort of like let the planet move forward again. We'll sort of get her spinning and kind of get it. We'll do another iteration of this. So what would happen in a week? So 4 minutes times 7 days, that's 28 minutes. That's almost a half an hour. That means stars you saw 1 week earlier appear in the sky a half hour earlier than they do when you see it a week later, a half hour, 28 minutes. What about a month? So what if we take 30 days, a 30-day month times 4 minutes? That's 120 minutes. That's 2 hours. 2 hours. So again, we had our start position. We had a zenith star over our head on April the 7th. 2 months later, that star will appear in the same place 2 hours earlier, or 1 month later, it'll appear 2 hours earlier in the night sky. And so this is really the secondary motion. So not only do we have that hourly motion, we see the stars rise, we see them moving across the sky, but we also have a motion that is seasonal, is yearly, is annual. The two things are happening. And the difference between the two is that magical 4 minutes. Solar time, sidereal time. A solar day, noon to noon, where the Earth becomes aligned with the sun at the same time it did 24 hours ago, and the time that the Earth aligns with the stars 4 minutes earlier. And that's really the secret. So do that. Let's do it more. So 120 minutes is 2 hours. That's 2 hours a month. In 3 months, that's 6 hours. In 4 months, of course, I'm going to stop this again because I can actually move forward. I'm going to erase the drawing part. I'm going to back out into space just a little bit. And I'm going to stop the spin of the Earth, but I'll just move forward. Let's just watch what happens in time as we move forward. This is just sort of like so. So now Afghanistan is locked on its noon sun, and the Earth is moving around our sun, our star. And you can see that little green dot way up at the top of the Earth there. That's us facing a part of the sky. You can see us moving around. Here we are in August. Moving forward a little bit more will be September, opposite of where we are in April 7th will be a little bit later. So I just got a little note to increase my volume. Sorry, I start to talk softer as I go forward. So this is really the magic I wanted to show you in the first part of the show. And in the second part, we're going to take a little break here for some question and answers, and we're going to take a little break for a poll and all that stuff. When we come back, I'm going to show you our night sky, but I want you to remember, just think through these two motions: the spin of the Earth, the solar day, the 24-hour day, the sidereal day that is 4 minutes shorter, and the movement of the Earth around the sun. And let's see how that all kind of locks into a way for us to observe the night sky and understand what constellations we see when and why we see them. All right. So I'm going to stop share here. It seems like a good time to take a little break, and I'm going to introduce some of the students to come on and kind of help us with some questions that might have come up during that particular part of the program. And we'll see where we go. And then I'll be back in just a minute with another program.
Thank you, Rick. Yeah, hi everybody. My name's Alex. I'll be launching our poll questions for tonight. So the first one is just kind of a general, quite literally a poll, not so much of a question, but have you attended previous night sky programs? Is this your first one? Yes or no? So once we get all those in, we'll move on to our next poll questions, and then we'll answer maybe some questions if we have any. Wow, so that's great. The majority of you so far have said you have attended night sky programs. About 80%. That's really good. We're so glad to have you back.
That's really good. That's great. Thank you, guys.
And the 17% who haven't attended before, welcome. We're glad this is your first one. We'll hope you'll be one of the returners. Okay, so I'll end that one. And then our second poll: why is Mars so bright in the night sky now? Its moons reflect light back onto Mars. It's closer to Earth than usual. It's giving off more energy. It's at its closest point to the sun. And then, do we have any questions that we want answered right now, Spoo? Do we have any?
Not yet, but I do encourage anyone and everyone to ask a few questions if you have any. Sure. We'll try answering them live and behind on the background. So go ahead and ask your questions, and maybe we can end the poll right now.
Okay, yep. So the results, a little bit closer than the last one. The two most popular answers were it's closer to the Earth and it is the closest point to the sun. The correct answer is actually it's closer to the Earth than usual. It's close to opposition. So it's a lot closer to the planet. Mars doesn't really vary enough from the sun to have that much of a difference in brightness, but its distance to Earth definitely varies a good bit. It can either be on the other side of the sun or right next to us in its orbit. So it is closer to Earth than usual. So that was our pulse break, and back to you, Rick.
Thank you very much. I'm going to share a different screen here, and this is actually another little thing for those of you that have seen this before. You've seen this quite a little bit. I really like this little program that we call Sky Safari. Unfortunately, with the iPad, it takes a little kind of work to get it launched, but here it is. And what I can do with this is we can kind of look at tonight's night sky. We can kind of talk a little bit about the constellations that are up right now. I'm going to show you some motions. I'm going to show you how some stuff works in the night sky based on that conversation we just had about seasons and things like that. And I can just kind of do it live. And I use a little pencil to make this work. Let me go get my pencil. I'm afraid I forgot to, my pencil was charging, so I just have to kind of sync it and lock it in here, and that should do it. And then we'll see where we go.
Rick, can you increase your volume just a little bit?
Yep, I'll sort of come up just a little bit more. How's that? I guess everybody can probably hear that a little bit better.
Thank you.
There you go. Thank you. So what happens here in this particular program is that everything that you see, let me just go now just to make sure we're in the right place. Everything you see within that circle is in your night sky right now. And I'll zoom in and we'll move around. We'll look at horizons and everything. But basically what this means is all of those things are above your horizon and they're visible now. And anything that is off the edges and in the green part is not in the sky right now. You can see right now the sun and Venus, for example, are below the horizon in the west. That makes sense. It's dark outside and they just drop below the horizon. You can see kind of looking at towards the south. Going to just kind of remind people for quite a little while in this last couple of weeks, we've been talking a lot about this particular part of the sky. It's the part of the sky that has the brightest stars from our perspective, the ones we get to see, and it's been up for a while. We've talked a lot about this little summer triangle right here. This is just a little recap, review. We talked about Castor and Pollux, the twins. They're in the sky over here. Taurus, the bowl, is here, and where Mars is also still up in the night sky in this particular area. I'm just going to get rid of this, and I want to sort of just kind of focus a little bit on Orion right now. Orion is this particular object right in the kind of middle of the screen. You've seen this before. We've shown you before. And when you go out after the program tonight and look out towards the south and towards the west a little bit, southwest is where this is going to show up, you'll see that big, beautiful constellation. It's one of our favorites. I wanted to remind everybody that last December, Alicia and Spoo did a program about that constellation. And when they did that, we were welcoming it to the night sky. So can you see it? I'm going to center on south. You can still see Orion in the sky. Let me just show you again. I'll just point it out one more time. We're going to be, I'm afraid I can't draw something and then let it stay, but we're looking at that particular constellation right there. And what I'm going to do is I'm going to just go backwards until December. Bam, 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 bam. And you can see Orion in this particular case is just sitting right on top of the horizon. And this is when we introduced everybody to Horizon. This is last December on the 8th. This is at 7:30 in the evening, and Orion is just appearing in our night sky. If I go forward again, month to month to month, you'll see, watch it jump sort of through, and it's easy to follow. Sirius is that really, really bright star down below the feet of Horizon, of Orion. There's January, February, March, and here's April. So tonight, I'm just going to move us ahead until about 8 o'clock. And that's when you're going to go look at it in the night sky. You can see that that's that movement. So what we were talking about earlier tonight, there's two different things going on. Any given night, you can see things rise from the eastern horizon set in the western horizon. But then month to month to month, there's also movement. And this is the movement that Orion has tracked over the last several months. One of the reason I point that out today is because before we meet again, in early May and then in later May, Orion is going to sink into the western horizon and get lost into the sun's glare. So it's a really wonderful constellation, and all of the bright stars around it are fun to talk about and fun to look at in our winter sky. But that period is almost over. So if you're going to get your fix on Orion, if you want to say goodbye to Orion, you're going to have to do it in the next week or so, because it won't be long. The sun is setting a little bit later. Orion is chasing towards the western horizon, and it won't be long before we lose it altogether. I also wanted to take a moment and have you go out and investigate Mars tonight. And so just to orient you again, now I'm looking directly to the west. You can see the little marker on the screen there. And the stars that are directly above the west here, almost directly above the strip, the one that says Aldebaran is part of the head of the bowl of Orion. And then you can see Mars is kind of just directly above that. Here, let me sketch for you. So here is the head of the bowl. And then these stars up here, way up at the top over here, are associated with the bowl's horns, or the tips of the horns up there. What we've been doing over the last several months, we've been kind of presenting about Mars quite a little bit. Mars moved over this way, went right in between the Pleiades and the Hyades, which is this V shape where Orion's head is. It's been moving in this particular direction, moving a little bit higher in the sky, moving away from the sun and up. in next couple of weeks, Mars will just split right through the horns of the bowl, right between these two stars. And so that'll be kind of fun to watch for as you sort of, if you're out there. And this is a good time for me to say that planets follow the same rules the stars do. Planets rise in the east, planets set in the west, but they also have their own movement. And so as the stars are moving down, Mars is joining them. Mars is moving kind of towards that sunset. We're going to lose Mars into the sun's glare in the next month or so, but it's also moving away from the sun at a very, very slow pace. So it's kind of got both of those motions going. In its orbit, it's moving further away from the sun. In our orbit around the sun, we're getting kind of around the corner, and it makes Mars look like it's sinking into the sun. So both of those things are happening at once. The trick is to watch it over the next couple of weeks, see if you can find it. It's a really nice red object. You can find the V, the head of the bowl. That's really easy to find. Aldebaran is a reddish star also. It's really easy to find. Notice which one is Mars, the planet, which one is Aldebaran, the K-type reddish star in the sky, and then watch its movement as it splits those goalposts as it sort of moves into space. I think that'll be a good thing to watch for. In this particular part of the sky, one of the brightest objects let me sort of orient again. So now I'm looking kind of more towards the northwest. You remember I started southwest looking at Orion. I went to directly west and above the west looking at the head of the bowl, Aldebaran and Mars. Now I'm looking over towards the northwest, and fairly high in the sky is a really, really bright star called Capella. Capella is also known as the goat star. And I always like to talk about Capella. And the reason to introduce it tonight is because it's Capella, as Sirius and Betelgeuse and Rigel are setting in the west, is going to be the brightest star in your sky for a while. It's very, very bright. Capella is part of a constellation called Orion. And if I could just draw it real quick and just sort of sketch here a little bit, if you go this way towards this star, this way towards here, which is one of the horns of the bowl, over this direction, over this direction, over this direction. You sort of see this kind of like elongated rectangular kind of shape. Orion is the Charioteer. So what we have here is a chariot driving across the sky. But in artwork and ancient ways to see this, the charioteer, the character that's driving the chariot, also had little goats in his arm. So he's driving with one hand, and in the other arm, he's cupping these little goats. And so that's really why Orion developed that particular name. I always like this because I like to show it to kids. So if there are any K-12 students watching, or if you have grandkids or kids, you want to show them, get them something to look at, a little bit of a challenge to look at in the night sky. Right next to Capella is this little triangle right here. It's just, we call that an isosceles triangle in geometry, right? And so these are fairly dim stars, but they make a really succinct, very easy to recognize little isosceles triangle in the sky. Those three stars are known as the kids. And I don't think you have to have lived on a farm before to know that kids are baby goats. And so this particular part of the sky, the chariot, the charioteer, the goats that he's carrying, Capella, the goat star, and the kids is part of this little triangle. That's a really, really kind of cool thing to look for. And I think kids like that because there's baby goats. Who doesn't like that? The last thing I want to show you, and then we're going to take another little break and then get on with the next part of our program, is the Big Dipper and looking towards the north. So now I have moved our sky view so that the northern north is on the horizon. And now you see, if you look over towards the west, that's Capella. And if you look over towards the eastern part of that horizon, the very, very famous asterism, the Big Dipper, is starting to appear in our sky. And the Big Dipper is really fun to watch because the theme of the show tonight was about time. Remember the spin of the earth, the 24-hour day, and the motion of the stars through the sky during seasons. The Big Dipper actually shows us both, the Big and the Little Dipper. So if you take these two stars, everybody knows this, the end stars are called Merak and Dubhe. If you follow them down They point to the North Star. This is Polaris. And if you remember in the first part of the program, when I was showing you that circumpolar motion, the star that didn't move, that's Polaris right there. Let me just sort of like, let me just skip through some months here and I'll sort of illustrate how that works. I don't know if I can move this or not. I have somehow, oh, I know what the problem is. I have to get out of the screenshot. So you can see the Big Dipper in the screen there. If I just move forward, I'll just do it days for a little while. If I just move day after day after day after day, same time of night, so this is 8:30 every night, we're looking at the sky at exactly the same time. And as I just bump through day after day after day after day after day, you see that the position of the Big Dipper changes. If I do this for like an entire year, you're going to find out that it changes by a full circle. And so that's really part of that motion again. And so we're just starting this adventure where it's high above the horizon towards the eastern side. Over the course of the evening, it'll move across the north and start going back down again towards the horizon. And week to week to week, month to month, you'll also see that movement. The same movement that you see in the nighttime also happens seasonally as it moves. And what was the difference between those two things? The difference was that 4 minutes. The difference between star time, 23 hours and 56 minutes, and solar time, 24 hours. So the Big Dipper, as it makes that giant circle in a day motion, will get back to the same place it was last night, 4 minutes early. And so what you see in this daily motion, if you look at the same time, is just it making up those 4 minutes every single step of the day. This is fundamental to understanding our view of the night sky. It's also fundamental to understanding the cultural significance of the sky and how it plays in everybody's calendar. 2 weeks ago, we were talking about the vernal equinox, and we were talking about how seasons relate to temperature and climate. We have summer and winter. We have those cycles that happen every single year. The constellations, what we see in the night sky, also cycle. They follow that movement. So if you lived in a time where you lived by the seasons, you were a farmer, you were a pastoralist, you had to plant things, you had to harvest things. If you lived in that time, you understood very specifically the seasons and what you had to do when to make everything work. If you were aware of nature and if you're aware of what's going on in the night sky, you would see the link. It would be so easy, right? The constellations in the sky at the same time, the seasons are happening on your Earth. What you're doing, what you're experiencing relates to the constellations and how they move in the night sky. This is the fundamental process of understanding cultural astronomy. Everything from, like we talked about 2 weeks ago, why Easter is when Easter is, why Bootes is up in the sky. The guy that invented the plow arrives in the sky at planting time and he leaves the sky at harvest time. These things, these stories across cultures and across time always relate to seasons and the view of the sky and how they operate together. And tonight we just want to kind of show those mechanics and show how that happens and talk a little bit about that magic 4 minutes, the difference between solar time and sidereal time, and how over the course of weeks, months, that changes our view of the night sky. All right, so I'm going to non-share screen now for a moment here. And then I will like open it up to the students so they can show some more poll and questions, and then we'll get on with the next part of the show.
All right. Thank you, Rick. So let's run the next poll. There we go. What constellations can you see tonight? The Big Dipper, the Little Dipper, Orion, the Summer Triangle. So go ahead and cast your polls while we take some questions. Alex?
Thank you. We have a couple questions. We have one from Nancy who asks, if Mars is at conjunction with Earth, does it appear as large as last October? I remember it seemed large and bright then. So a few things. Right now, Mars is close to opposition. Conjunction is when Earth and Mars are on the opposite side of the sun. So that's when it says its farthest point and we can't see it. But opposition actually happened just recently. That probably is what you're remembering back in October. That was when Earth and Mars were at their closest points in their orbits. That's when it was the brightest and largest as it was in the night sky. We actually had a show back then talking about that. It's still close enough now where it is still bright, but as it starts to go closer and closer to the conjunction, it'll be behind the sun and we won't see it for a little while. But yeah, that's a October was that point when it was closest. And then Charlotte, who is in kindergarten, asks, can Perseverance see stars from Mars? Yes, it's not as often as it likes to look at rocks, but yes, occasionally these rovers will stop and stargaze. Sometimes it'll get a planet of some stars. It'll get pictures of maybe its moon, Phobos, of Mars. It'll get pictures of even Earth and Venus. There have been pictures from the Curiosity rover of us. But yeah, Perseverance will probably do the same mission task where occasionally it'll look up at the sky and see if it can get anything. So yeah, that's a very good question. Okay, Spoo, back to you for polls.
Questions?
Thank you, Alex. Okay, let's end the polls. And here you go. So what kind of constellation can you see tonight? The Big Dipper, 75%. Well, that is reasonable. That is reasonable.
I'm afraid we have actually tricked people with this question.
Yeah,
So
we have.
yes. So explain, Spoo. Why is the Big Dipper even a constellation?
Okay, so the Big Dipper is what we call an asterism, which means a part of the constellation. So the constellation is Ursa Major, which is mostly called Big Dipper because it looks like a big frying dipper, but that is the asterism. It's not the entire constellation. So if we ask what constellation can you see tonight, it's probably going to be Orion or
Orion and the Goat
Orion.
Star and the kids, and the ones we kind of just all talked about. So the Summer Triangle is also an asterism, so that's not a constellation either, and nor is the Little Dipper. So really, the only constellation truly on this chart is Orion, and that would have been the correct answer. We'll probably have to go over that again in a couple of weeks just to make sure people know. Thank you, Spoo. Hey, audience, we wanted to do something. We were going to just reviewing some of the stuff we've done in the past and sort of like when it's time to redo thing. And every once in a while this comes up is we'd like to share a resource. So what we're going to try to do for a little while, at least every other week, is instead of doing a whole bunch at once, we're going to try to just pick a resource, something you can kind of look at on your own, something that's available to you that you can find and learn a little bit more about the stars and skies and missions and things like that. And so tonight, we've asked Kim Baptista, your webmaster, to spend a little moment telling us about our website. And so I'm going to introduce Kim, and she's going to show you how that works and how to find it. Thanks, Kim.
Good evening, everybody. Let me just share my screen, and I'm just going to share our website, which I think will be helpful in just letting everybody know like where they can find all the things that are happening in the School of Earth and Space Exploration. So last fall, we got this nice new redesign of our landing page. And so this is what it looks like when you first get to our page. You see across the top here, we have our decree programs that you can check out if you're interested in what we're offering. This drop down is for our centers and initiatives that we're associated with. And then one that's really probably going to be of interest is this is our research. And then if you click over here on space exploration, if you click on here, this will take you to all the missions and instruments in flight that we're part of. And so the Mars 2020 rover Perseverance Mastcam Z, here's all the things related to that. But then if you click on the ones in development, these will also tell you the ones that we're part of and that are going to be launching in the future. There's also the community engagement tab, which is where you'll find events. And I'll apologize, I'll click on here, but my browser shows it differently than a lot of other people's. But this is where you can find events related to the School of Earth and Space Exploration. So like here's tonight's Marston Theater Virtual Night Sky presentation and all the future ones that are coming up. You can also click over here to find our leadership team and the people that work at the School of Earth and Space Exploration. Student life, and then about. And if you go to our about, if you click on news, you can find the most current news events that are happening for the School of Earth and Space Exploration. And if you scroll all the way down to the bottom of this page, this is where you can find, all of our, let me get out of here, I'll go back to home. You go all the way to the bottom of our page, this is where you can find all of our social media platforms. So Facebook, Twitter, LinkedIn, YouTube, Instagram, and this is our Flickr page with all of our photos from the School of Earth and Space Exploration. So lots of resources here for you. And if you have any questions, please send me an email and I'm happy to help walk you through and find things. But probably for the events, for registering, this is where you want to go for the next one.
Excellent. And it's going to be an amazing show. So this is really important. We really wanted, Kim and I wanted to show you this because we only have time in our hour every other week just to kind of just hit the surface. I mean, we're going to try to get you updated on sort of the latest and the greatest and the things that are really important to us, but there's so much going on all the time. And so not only can you dig a little deeper, if you hear something you like in the show tonight and want to hear more about it or see more of these things, that's the place to go. So to find that, especially about the missions, because there's so much information about missions, and then there's links, and that can take you into all kinds of different directions. There's so much information, but we're just going to encourage you to use our website as the start for this. And when you want to find out what we're doing, lectures and things coming up, this is a really good place to go, see what's going on. Thanks, Kim. Anything else?
And I just put the link to our website in the chat for the audience. So thank you.
It is actually really easy. We call it the School of Earth and Space Exploration's initials are SESE. Call that CC, SESE at asu.edu or .asu.edu is going to take you there. It'll just get you to the webpage, and you won't get confused. You're not going to find anything else. It's going to be us. So good place to do that. The next thing we wanted to do, I promised at the beginning of the show, some really exciting stuff going on Mars right now. And we've been, just everybody on the Mars team has been very excited about this little helicopter, this little drone thing, and it's about to fly. And Alicia, can you tell us about it and what's going on?
Yes, I would love to. So hi, everyone. My name is Alicia Hyatt. I work at the School of Earth and Space Exploration with everyone you've met tonight. And so I am going to introduce a new segment to our show as soon as I share my screen. Awesome. And this is called Current Events. Awesome. So I get to present to you, or someone on our team will present to you, whatever information you want to know for the following week. So this week, we have the Mars Perseverance rover, the Mars 2020 rover. And so I'm very excited to talk to you about this because it has been making a lot of news recently, and I'm pretty sure it'll continue to make a lot of news. And we also really care about it here at ASU, and I'll explain that in a minute. And so the Mars 2020 rover, or Perseverance, was one we've been working on for a really long time. So ASU actually built one of the instruments on this spacecraft, or on this rover, excuse me, and we'll talk about that shortly. But I want to talk to you really quickly about kind of the timeline. So we found out in early 2014 that ASU was selected to build the MATCAM-Z instrument. And so it's been a 7-year-long process. And so 7 years to build this instrument or so, with 7 months of travel. So we launched the Perseverance rover on July 30th, 2020. And it was cruising for a while, about 7 months, until it entered Mars's atmosphere and went through descent and landing on February 18th, 2021. So not that long ago. And during that period of time on that day, we have what we call our 7 minutes of terror. And that is when we have zero control anymore. It's kind of one of those things where whatever happens, happens. And we all kind of just cross our fingers and our toes, because any changes we would make at that point, they wouldn't get to the rover, wouldn't get to the spacecraft in time to make any changes anyway. So it's kind of 7 minutes of terror and just wondering what's going to happen. But Perseverance did make it just fine. And so we started surface operations that day, and we are continuing them. And so the Mars 2020 rover had, or the actual spacecraft had 25 cameras on board. The rover has a little less than that because we were able to attach some to watch the parachute and the landing and so on and so forth. But two of the cameras we really care about at ASU because we got to build them here. And so that's the Mastcam Z, as you can see on the right side of the screen. So these are two cameras that attach to the mast, right? Scientists are super clever with their names. And what this camera or these cameras are able to do that previous cameras that we have built weren't able to do is this is able to zoom, right? That's what the Z stands for. So these cameras can actually zoom and take stereo or 3D images. They can also take panoramic images, 360 degrees, 90 degrees up, 90 degrees down. So lots and lots of angles, any you can imagine. So we are very excited to see what Perseverance brings to light. I'm going to quickly go on here because we're running out of time. But on the right is the first image we received from Perseverance when it touched down. And on the left is the first color image we received from one of the cameras. And then this is the first 360-degree panoramic that was taken by the Mastcam Z. And so how this image was taken was it was 142 images put together in order to create this beautiful panorama that we just saw. And so as you can see, all of these 142 images are being placed together to give us that panorama we saw. And so I'll let this finish. It's almost done. But yeah, so lots of brain power went into making sure these cameras worked successfully. And we continue to look forward to what we have to learn from Perseverance and the images that we get back, but we are very excited about Ingenuity. So for those of you who didn't know, the Perseverance rover is very special because it has our first ever helicopter component to any sort of rover. So Perseverance has a little buddy and its name is Ingenuity. And so here's a little selfie of the two of them. And so just for a sense of scale, there's about a 13-foot difference between between Perseverance and Ingenuity. And so Ingenuity will actually begin flight in the next couple of days. We're very excited about. And so this was an image taken by the Mastcam Z of Ingenuity after it had survived its first night on the Martian surface. So that's a very big step for us, knowing that it survived its first night and it didn't freeze. So we're very excited to see all of the data that we're going to get, not only from Perseverance, but also from Ingenuity, the helicopter as well. And we believe that's going to launch or start flight April 11th. So keep checking back for that. But Rick, I will go ahead and end right here so you can, actually, I lied. I'm going to stop sharing really quick. And for our next segment, or for our next show, I'm going to go ahead and start a poll. And I want to know, or we want to know, what you guys would like to learn about, what everyone wants to know. And so what future topic would you like to learn more about? You could choose one or multiple, so student research, current and future missions, meteor showers, or astronomy and culture. So thank you so much. Please cast your votes, and I'm going to pass it back to Rick.
Alicia, let me just ask, just to clarify, so you can pick more than one? Or you have to pick one?
Thought so.
Yeah, maybe you can.
Yes, Kim says yes.
Yep, it's adding up to more than 100%, so I guess that's probably true. Oh, good, okay.
We've grown.
Good. Oh, I think that's good. Yeah, this always helps us. We do these webinar formats, and you guys will have a chance to participate in a survey in a couple of days. you'll get that as an email, and we really use that. I mean, we listen to what you want to see, and we'd like to hear what you, and we program accordingly. So if you have something you want to do, now you have the website, and you can actually look up our emails. You can actually find stuff about the staff on there, and start telling us and start a dialogue, because we're usually live, and we usually have an audience with us, and we usually get to talk, and this is really a one-way communication. We don't like it, so we want you to participate that way. All right, I've got one more really cool thing to show you. So this is about sort of things coming up, and I think we're going to go over by a minute or two. But Luna and I, some of you guys know Luna, we made a little video, and so I'm going to use this video to be a little bit of a preview of something of next 2 weeks from now. This is going to be a little bit different for us, so I hope you guys like it. Hang on a second. Let me just share that. And let me push start. And there you go. Hi, everyone. Luna and I are in the Phoenix Mountain Preserve near Piestewa Peak. We'd like to use this place as one of our regular running spots. Luna likes it because she finds bunnies out here. I like it because there's a little piece of nature near my house that I can enjoy on my morning runs. If you look down that way, down the trail, there's a Phoenix park named Granada Park. There's a lake there, lots of ducks for Luna to bark at. If you look up in the other direction, that's Piestewa Peak. In 2 weeks, we're going to be celebrating Earth Day, and our guest at our virtual night sky program will be Dr. Steve Simpkin from the Arizona State University School of Earth and Space Exploration. Steve is going to be presenting to us about geology in Arizona. Luna and I are out here looking for a couple of rocks, and we're going to ask Steve to identify them and learn what they tell us about the origin of Piestewa Peak, and then maybe something about the geology of the Phoenix metro area. Okay, here's the rocks we found. Let's see what Steve has to say about them. All right, that's our little attempt to sort of get you ready for geology. We are a Earth and space organization. That's what we do. Our school is about geology of the Earth and about astrophysics and the astronomy and cosmology of space. And so Earth Day is on April the 22nd. Our next program, 2 weeks from tonight, is on April the 21st. And so we've invited Steve to come. We'll have a talk about Arizona geology, what you see when you're driving up to the Grand Canyon and around the state and what it means. And then we're also going to have that little segment about, like, right here in Phoenix, when you look at the mountains, you can actually sort of like see some geology just firsthand. Steve will tell us what we're going to be looking for. So we'll have that. The very next night is part of a program we call the New Discoveries Lecture Series. Oh, there's Jackie. There's my wife. So Luna wanted to say hi tonight, so I just wanted to sort of like get her to say hello. Do you enjoy looking for rocks, Luna? And Luna loves whatever this is we're feeding her too. So anyway, New Discoveries Lecture Series, and in this particular case, we will have guest 2 professors from ASU, and it's different than the virtual night sky. This is actually a program that happens about once a semester. You can find the way to register for it on that website that Kim showed you, or you can find the link is in our chat right now, so you can find that. In this particular case, we're actually talking about a collaborative science and engineering and exploring desert ecosystems. The professors are Heather Throop and Nanishwa Das, and they will be working together, kind of team tagging a presentation about science and engineering and desert ecosystems. So that is the day after our next program on April the 22nd. I have nothing else. I'm going to come to a close. We love that you guys are coming back every week or every other week and seeing us. We will kind of keep programming. We've got lots of good ideas going into the future, so keep checking in with us. And again, you'll get that survey in a couple of days. You'll see it, and thank you very much. If you don't mind just taking a moment to say you like what we were doing, or you'd like to see more of this, you'd like to see some of that, or you have a question, something, some burning question about Earth and space sciences that you'd like to understand better, we will make sure that that's part of our program. So thank you, and keep looking at the night sky. Thank you. Bye-bye.